Hi, all right, in this video we're going to look at some free fall calculations together. So here's a table with the equations, and of course we've already talked about all these variables. VF being final velocity, the VI, the initial velocity, G for gravity, T for time, and D for displacement. I will point out that a lot of times the D for displacement you could see as the change in Y values or the change in X values, because really the displacement is the change in position. So for free fall, because it's all vertical motion, it's going to also be looked at as the change in Y values. So for this table of equations that we have here, you can see that on the left-hand side it says use when the initial velocity, VI, is 0. So this would happen anytime that you drop the object. Anytime it's dropped, the initial velocity is always 0. So it's just the simplified form of the original equation. You'll see that it doesn't have the adding of the initial velocity like over here. For 1. So an object falls from a high building, ignoring air resistance. What will its velocity be after 6 seconds of falling? So we know the time is 6 seconds. As always, we know that gravity is the negative 9.8 meters per second squared. And for this one, we're asking, what is the velocity, the final velocity, after it's been falling for the 6 seconds? So from this one, it doesn't give us an initial velocity, so we assume it was dropped. So that means that our initial velocity would be 0. It means we can use any of these equations on the left-hand side. We know that we're looking for the final velocity, so this equation or this equation could work. But if we look at what we're given, we're only given the time and the gravity. So time and gravity is present in the first one, but in that bottom equation, we need gravity and displacement, and we were not given that, so we cannot use the bottom equation. We have to use the equation on top, VF equals gravity times time. So the final velocity is going to be equal to negative 9.8 meters per second squared times the time of 6 seconds. And once you plug that into your calculator, you should get that it is 58.8 meters per second. And it was a negative times a positive, so it is a negative 58.8. Or you can think of it in terms of, well, the object was falling down. Down is negative. Problem number 2. An object falls from a high building and hits the ground in 9 seconds. So for this one, we already know that our time given is 9 seconds. Ignoring air resistance, what is the distance that it fell? So for this one, we need to know the distance, or essentially the height of the building. As always, we know gravity. And so far, that's all that we know. So because we have time and gravity, and we're looking for distance, we have to use this equation. And I'm using the equation on the left-hand side because, again, it doesn't tell us that there's an initial velocity. The initial velocity we assume is 0 because it doesn't give us an initial velocity. We assume the object is dropped. So that means we could have used any equation on this left-hand side, but because we're looking for the distance, it has to be this middle one. So our original equation is distance equals 0.5 times gravity times the time squared. And make sure you're only squaring the time, not your entire right-hand side of your equation. So distance equals 0.5 times gravity, the negative 9.8 meters per second squared, times the time squared, which is 9, so 9 squared. So essentially you'd have 0.5 times 9.8 times 81, and that should give you 396.9 meters. And it was a positive times a negative times a positive, so your answer would be negative. Now, I know you can't have a negative distance, but the displacement that the object fell in those 9 seconds was down 396.9 meters. So the distance that it fell would just be the 396.9 meters. All right, number 3, during a tornado in 2008, the Peachtree Plaza Westin Hotel in downtown Atlanta suffered damage. Suppose a piece of glass dropped near the top of the hotel, falling 215 meters. Part A, and this is a multi-part situation. Ignoring air resistance, how long would it take the piece of glass to hit the ground? All right, so we were told a couple of things in this one. It did actually tell us that the glass was dropped. And again, if it's dropped, that means our initial velocity is 0 meters per second. So already that tells us we're going to keep using our equations on the left-hand side. It says that it fell 215 meters, so that would be our distance or our displacement. For part A, we are solving for how long, so we're looking for the amount of time that it fell. So knowing that we were given the initial velocity is 0, so we can use anything on this left-hand side. And as always, we know gravity is the negative 9.8 meters per second squared. We were given displacement and gravity, displacement and gravity, but we are solving for time. So if we look at our top equation, we were not given the final velocity, but we were given the gravity, but we weren't given the time. So we have two missing variables there. We cannot use this first equation. For our second equation, it is distance equals 0.5 times gravity times the time squared. So we were given the distance, we were given the gravity, and we are solving for the time. So this is the equation that we will need to use. We can look at the third equation, VF equals the square root of 2 times gravity times distance. We were given the gravity and the distance, but we are not looking for the final velocity. We are looking for time. So we can't use that one either. So plugging into our original equation, the distance equals 0.5 times gravity times the time squared. So we're plugging in our distance to be 215 meters equals 0.5 times the negative 9.8 meters per second squared times the time, which we are looking for, and the time is squared. All right, so if we simplify the 0.5 times the negative 9.8 meters per second squared, that will give us 215 meters equals negative 4.9 times t squared. We are trying to find the time, so we need to get t on a side by itself, so we need to divide by the negative 4.9, divide by the negative 4.9. And technically speaking, the 215 meters, the object did fall downward. So really our displacement should have been a negative 215. And sometimes you catch these mistakes as you're working the problem because you know time should end up being a positive number. So that was where we went wrong for this one. So 215 divided by 4.9 is going to give us 43.9, and that is equal to our time squared. But we don't want the time to be squared. We want a regular time. So we need to take the square root of 43.9, and that's going to give us a time of 6.6 seconds. And remember, we did take the square root in order to get that answer. All right, number 4, same situation. So we know that the time that it took, we just solved, was 6.6 seconds. We know that the displacement was a negative 215 meters because it fell downward. We know gravity, as always, to be the negative 9.8 meters per second squared. And for this one, part B, ignoring air resistance, what will the velocity of the piece of glass be when it strikes the ground? So now we're looking for the final velocity. So if we know the time and we know the displacement and we know the gravity, and I'm using this method of underlining everything that you were given because it helps you see which equation you should be able to use. And again, it's dropped, so we were given an initial velocity of 0 meters per second. So that's why we're using the equations on the left-hand side still. Well, based on what we're given, we could use this equation, VF equals gravity times time, because we are given both gravity and time. We could use the equation on bottom, VF equals the square root of 2 times gravity times displacement. So let's use the bottom equation. We haven't used that one yet. But either equation would give you the correct answer. All right, so VF equals, of course you can't take the square root of any negative number, so any negative signs would have to be outside of the square root. So square root of 2 times gravity, which would be the negative 9.8 meters per second squared. Again, negative sign stays outside the square root. And then our displacement would be the negative 215. Negative stays outside. So two negatives would make a positive. Even if you had left them under the square root and you multiplied first, negative times negative is a positive. So when you take the square root of 2 times 9.8 times 215 in your calculator, that is going to simplify to be 64.9 meters per second because we were looking for a velocity. All right, number 5. Now we're looking at the Transco Tower in Houston, and it says that it takes 15 seconds in order for it to reach the ground. Obviously, gravity is still the negative 9.8 meters per second squared. This would never change unless you changed planets or went to the moon. For part A, what is the velocity at impact? So the final velocity, if air resistance is ignored. All right, so for this one, we are given time and gravity. We are going to need to use this first equation to find the final velocity. That is what we are looking for. I'm staying on this left-hand side because we were not given an initial velocity. We assume it's 0. We assume that the object was dropped off the tower and not thrown. So VF is equal to gravity times time. So VF is equal to negative 9.8 meters per second squared times the 15 seconds. So when you plug this into your calculator, you should get 147. It would be negative in meters per second because it is velocity. It has to be negative because, again, negative times positive is a negative. But also, if you think about it, the object is falling down. Down is negative velocity. All right, last one. An object falls from the tower again, so we know that the time is 15 seconds. Gravity is the negative 9.8 meters per second squared. We know that the final velocity that we just calculated was 147 meters per second. The initial velocity we assumed was 0 because it doesn't give us an initial velocity. We assume it was dropped. So we're looking for how tall is the building. So that would be a displacement. How far did it fall? That would tell us how tall the building is. So to find displacement, we would use this equation. Distance equal to 0.5 times gravity times time squared. So displacement is equal to 0.5 times gravity times the time, 15, and only the 15 gets squared, remember that. So when you plug this into your calculator, you should be getting 1,102.5 meters because this is distance or displacement. Technically, it's a negative value because the object did fall the 1,102.5 meters. But when you say how tall the building is, you wouldn't say a negative value. You would just say, oh, it's 1,102.5 meters.